Hey everyone! Today, we're diving into the fascinating world of ancient marine reptiles and a discovery that's got the paleontology community buzzing. Specifically, we're talking about a creature called Austronaga minuta, a small Triassic marine reptile that's been preserved in a way that's truly extraordinary. This reptile, which lived around 245 million years ago, has given us a glimpse into its internal organs, including its stomach, liver, and intestines, all remarkably intact. Let's explore why this is such a big deal and what it tells us about the evolution of early sea reptiles. First things first, the fossil was found in southern China, in a place called Luoping, which is known for its rich fossil beds. The reptile's skeleton was found on 2 limestone slabs, and what's truly remarkable is that its internal organs, including its stomach, liver, and intestines, were preserved as well. This is a huge deal because no older reptile organs are known from anywhere else. The fossil is about 24 inches long and has a long neck and tail, and it's carrying its last meal with it, fish scales, still sitting where the gut used to be. Now, let's talk about the organs. The dark smear between the reptile's ribs, which initially looked like nothing much, turned out to be a large, sac-like stomach at the front, followed by a strikingly red liver with traces of hemoglobin. Behind this is a long, simple tube forming the small and large intestines. The liver's color is not a trick of the light. Iron from hemoglobin appears to have mineralized in place, leaving a framboidal iron-rich residue that the electron microscope picked out against the surrounding rock. One of the most fascinating aspects of this discovery is the preservation of the reptile's last meal. Farther back, between the last dorsal vertebra and the first sacral, the intestinal contents survive as dark brown masses with smooth surfaces. The front section loops narrowly, while the rear is thicker and three-dimensional. Inside that rear section sit pieces of undigested food, probably including the glossy ganoid scales of fish. Phosphate is concentrated there far above the levels found elsewhere on the slab. Now, let's talk about the reptile's digestive system. Modern birds and crocodilians have a 2-part stomach, but Austronaga had a single chamber. This suggests that the stomachs of archosaurs were initially quite simple and only evolved later in the evolutionary process. The intestine is also short and loosely coiled, with no expanded colon, which is closer to the gut of a fish-eating monitor lizard than to the long tract of a plant-eating tortoise. One of the most interesting aspects of this discovery is the reptile's limbs. Its forelimb is more than twice the length of its hind limb, a humerus to femur ratio of 2.19. This is a hallmark of flippered swimmers such as plesiosaurs, ichthyosaurs, and whales. The claws are gone, and the joint surfaces are flat and barely formed, which would have made movement on land clumsy at best. Now, let's talk about the reptile's family tree. Austronaga belongs to Tanysauria, an early branch of the lineage that later produced crocodiles, dinosaurs, and birds. Its closest relative is Dinocephalosaurus, the long-necked, Chinese dragon, described in detail from the same part of China. This family tree matters because the other famous sea reptiles of the Mesozoic have no clear land-dwelling relatives, and ichthyosaurs and plesiosaurs enter the fossil record already committed to the water. Finally, let's talk about the limitations of the study. The organ identifications are interpretations, and the paper says as much. Stomach, liver, and intestines are read from position, size, shape, and chemistry, not from preserved cell structure. The liver is incomplete as well, and its front portion appears to lie beneath the stomach, so the organ was probably larger in life than the exposed layer suggests. In conclusion, the discovery of Austronaga minuta is a fascinating one that has given us a glimpse into the internal organs of an early marine reptile. By preserving the oldest known reptile organs, this fossil provides an unusually complete picture of how one of the earliest marine reptiles lived, fed, and adapted to life in the sea. It's a reminder of the incredible diversity and complexity of life on Earth, even in the distant past. So, what do you think? What makes this discovery so interesting to you? Let me know in the comments below.